melt.
Yes, sir.
After of melting, where will it spread? The material will spread on the surface itself, correct?
Yes, sir.
The material spreads on surface. What will happen to pressure now? Will it not get eased?
It will get eased.
Why? Because area increases, so pressure will get eased.
Yes.
As pressure gets eased, temperature will decrease, correct?
Yeah,
Yes.
yes, sir.
Yes,
And
sir.
as temperature decreases,
You stop
the
melting.
two surfaces which are in contact will fuse.
Yeah, yes, sir.
As temperature decreases, the two surfaces which are in contact will fuse. And this is the only process which explains on mechanical front why do we get something which we are to next name friction. Why do we get something which we did just name friction? Why does exist friction between two surfaces in contact? This process is called cold welding. This process is called cold welding. Owing to ease on temperature, the two surfaces fuse, and if you now want to move one surface on the other, you will have to break this microscopic belt or microscopic rivet which is being generated, correct?
Yes,
Yes,
sir.
sir.
It doesn't ask for even a bat of your eyelid. It doesn't ask for even a fraction of the time taken for your eyelid to bat. The moment you place dongle on table, process done. The moment you place dongle on book, process done. Friction has got established. There is a microscopic rivet now. There is a microscopic belt between book and dongle. Yes, that microscopic belt doesn't doesn't show off. It will not show itself. It has established, but will not show itself. You will not be able to realize it. When will it show? It will show if and only if you disturb its state. Till the time you are not disturbing its state, it will not show. Though it has got established, it doesn't show. Established doesn't ask for even a fraction of second. In a jiffy, it got established. It will not show. When will it show? It will show only when you disturb its state. Is it okay? What did I tell you, dear?
Yes, sir.
Yes,
So
sir.
there are different aspects involved over here. Please differentiate. Please distinguish between the two. Is friction there established already? Yes. Why then I don't show friction acting? I only show normal and mg because it is in balanced state. When will it show? When I try to tilt it. Is it tilted now? Is it tilted now? Still the dongle is not moving. Are you getting it?
Yes, sir.
Still the dongle is not moving. Let me not move it. Still the dongle is not moving, right, dear?
Yes,
Yes,
sir.
sir.
But normal is acting this way and mg is acting vertically downwards, correct? So normal is in no position to balance mg. Tell me, why did I tell you this? Because normal and mg are not acting in opposite direction, correct? For
Yes,
forces
sir.
to balance, they should have same magnitude and act in, they should be equal and act in opposite direction, correct? So
Yes.
here you justify normal upward, mg downward. They are balancing each other, right, dear? But when you tilt, what happened? Normal is not aligning with mg, correct?
Yes, sir.
Still the dongle is not moving, correct?
Yes, sir.
That means there must be a force other than the two.
Yeah.
Must be a force other than the two. Are you getting this? This is very important here to understand. Till the time, I show you over here. Till the time book is kept on table, normal is acting upward, mg is acting downward. We don't have any qualm. They are balancing each other. So we are good. We are good in our skin. They can balance each other. Why? They are aligned. Correct?
Yes, sir.
Now what I do? I take the book slightly. I tilt it by an angle theta. And we are still into observing no motion of the book. Normal acts this way, mg acts this way. Of course, mg is in no position to balance normal, correct?
Yes, sir.
We resolve mg into component. In this direction, we will get mg sine theta. Why? Because the angle is 90 plus theta minus theta, and in this direction we get mg cos theta. Please look into it and get with this resolution also attuned. Those who are new to it, please get attuned with this resolution as well. If a force is in this direction, you can resolve it in rectangular component. Rectangular component means perpendicular component. If this is theta, in this direction you will write mg cos theta, and in this direction you will write mg cos 90 minus theta, which will be sin theta. Correct here, Adesh and Vedant?
Yes, sir.
Okay. So here it was 90 minus theta, therefore mg sin theta for this and mg cos theta for this. As the book is not moving, so normal and mg cos theta, they are balanced, correct?
Yes, sir.
Yes, sir.
But what about mg sin theta? This is not balanced, correct?
Yes,
Yes,
sir.
sir.
But book is not moving. So there must be a force acting in the upward direction, which must balance mg sin theta, correct?
Yeah.
Yes, sir.
Otherwise, the book will move. Book will have to move. Correct, dear? Are you understanding the predicament that I am in?
Yes, sir.
So the predicament being there is mg sin theta acting in downward direction, yet the book is not moving, which is counterintuitive. Why? Because if there is a force, then it will tantamount to an acceleration. An acceleration in due course of time will make the book move. Correct, dear?
Yeah. Yes,
Yes,
sir.
sir.
It is not moving, which is suggestive of there being a force of the inclination equal to mg sin theta, correct?
Yes, sir.
Yes, sir.
Now we show that force, and that force did show. It got established here as well. It got established here as well. I told you that. It has got established. But it shows when there is a tendency of block to move. Mind my words. When there is a tendency, it gets established, but it is no business of show off. It will show only if there is a tendency of the block to move. By tendency on technical term, I mean there is a force which is unbalanced. Clear?
Yes, sir.
Yes,
So
sir.
one doubt.
Force in this case which was unbalanced, it did show. And that is what we say is static friction. This is the friction force and is static in nature. Why so? Because the block is not moving. There is no relative motion between the surfaces in contact. Correct?
Yes, sir. So one doubt.
Yes, dear.
Has it been ever? Has it been possible till date that there is any surface when while moving there's no friction? Has it been possible?
So we have never yet got, as yet we have not got zero frictional surface. Zero frictional surface is an idea, is something that we have ideated. Something that we have ideated may not be able to realize, right? Yeah. Those are
Yeah.
ideal. And we are to adulterate it. As we know that in order to bring it to practicality, we need to adulterate something which is pure.
Yes, sir.
Okay, so we have not yet established. Yes, we can reduce it. by greasing, by oiling, and that is what we use.
Yes, sir.
We use the process of greasing, we use the process of oiling.
Yeah.
Right, India? Yes, Adesh, you were also asking something.
No, sir. No, sir.
Is it okay? So
Yeah, it's okay.
this is the force of friction that you have, and Fs over here, the subscript is indicative of it being static in nature. By static, I mean that it is acting, but there is no relative motion between two surfaces in contact. Clear, dear?
Yes.
And
Yes,
according
sir.
to Newton law of friction, again Newton, according to Newton law of friction, static force of friction is directly proportional to normal existing between the surfaces in contact. Please write that down. Static force of friction, static force of friction is directly proportional to normal existing between is directly proportional to normal existing between the surfaces in contact is directly proportional to normal existing between the surfaces in contact. So if we remove the sign of proportionality here, then we place a constant of proportionality, and this constant of proportionality is called coefficient of static friction. Is it okay?
Yes, sir.
This constant of proportionality is called coefficient of static friction.
Okay. Yes, sir.
Yeah.
Yes, sir.
Food for
Yes,
thought. You will think about what can be the maximum value associated with coefficient of static friction. Do we have any
Okay.
rider on? Think about it. What is the maximum value to be associated with coefficient of static friction? Do we have any rider on it?
Sir, it should be
Any
1.
rate?
So the maximum
Okay.
value should be 1.
Okay, fine. We'll think about it later. I have asked you to give a thought to it. Just spare a thought and think about it. We'll discuss on it later. Also, I ask you, is there any time gap between action and reaction force? Is there any time gap between action and reaction force, or they are simultaneous? So think about this as well. We'll be discussing on these two questions later. For now, Fs is equal to mu into normal. Mind you, I didn't say anything. I have not said a word on direction. I have told you everything on magnitude. Magnitude of static friction is directly proportional to normal and is equal to mu s into normal, where mu s is called coefficient of static friction. Is it okay?
Yes,
sir.
sir.
Clear, dear? So if you want to move a block and block, you apply 1 Newton of force, block doesn't move. You apply 1 Newton of horizontal force, block doesn't move. Then what will you say? Which force is stopping the motion of block, or which force is countering your force? You apply 1 Newton, block doesn't move. So there must be a force which counters your force, right dear?
Yes,
Yes,
sir.
sir.
You have applied force horizontal, that means parallel to the floor. You have not applied perpendicular, parallel to floor, but it doesn't move. What is this suggestive of? There is a force which is countering the motion, which is countering your force, correct? And that
Yes,
force
Yes,
sir.
should be
sir.
what on quantum? If I have applied 1 Newton, that force should be what on quantum? How
So
much
Uh,
1 Newton.
cancel my force? I have applied 1 Newton. The block doesn't move.
It should be 1 Newton. Friction should be 1 Newton.
Equal.
Should be 1 Newton. And it should be in which direction?
yeah.
Opposite.
Opposite.
Direction
Opposite.
opposite to the direction in which I have applied. Okay, I increase it to 2 Newton, it is still not moving. So which force is refraining it from move?
Friction.
Friction.
Friction again. So what has happened to friction now? Did it increase its value?
Yes, sir.
Yeah.
Yes, sir.
I have applied, I have increased my value to 2. So friction has also increased it to 2, right dear?
Yes, sir.
Yes, sir.
Yes,
Will
sir.
it keep on happening ad nauseum, or there will be a limit to it?
So there'll be a
Limit.
limit to it.
Will you never be able to move that block? Or if you gain
No,
on
sir.
strength, if you gain on strength sometimes, someday you'll be able to move it. What say you? Tell me.
Yes, sir.
Yes, sir.
You'll be able to. Will be able to. That means there should be a cap on friction force.
Yes,
Yes,
sir.
sir.
Yes, sir.
Can we see that? there should be a cap on friction force. Beyond that,
Yes.
it cannot increase, correct, dear? It cannot go any
Yes.
further.
Yes, sir.
Yes,
Right, dear? Suppose I apply now 2.000001 Newton. Is it okay? What did I
Yes, sir.
apply? 2.000001 Newton. And I found that now the block got tweaked. It started moving. Clear?
Yes, sir.
yes,
So what will I say about friction? I will say that there was a cap on friction which was equal to 2 Newton, correct?
Yes,
yes,
sir.
sir.
Will I or not? Tell me, dear, all of you.
Yes,
I'll
sir.
say
Yes,
that there
sir.
was a cap and that cap was equal to a what quantum? Of quantum 2 Newton, correct?
Yes,
Yes,
sir.
sir.
Can we go in make a statement or will I be going overboard? If I say that static force of friction is self-adjusting force.
Yes, sir.
Can we make that statement? Can I make a statement to the effect that starting force of friction is self-adjusting force? Think about it. 1 Newton I apply. I was nothing to do with
We can.
what
Yes,
friction is doing. I have no inkling why it is not moving. Yes, rationality says that if I'm applying 1 Newton and if it's not in motion, then there must be a force which is countering my force. Correct, dear?
Yes,
Yes, sir.
sir.
So you can
yes,
tell
sir.
that statement, putting a rider on it, that it's not it's only self-adjusting to a certain point. Because if it was
Correct.
self-adjusting, it'll always be at rest.
Not be ad nauseum. It will not be ad nauseum. It will not continue up to infinity. Yes, there is a rider on it. There is a cap. There is a cap. So it will increase. Of course, it will increase. And that increase will be linear. That also I know why. Because I applied 2. I applied 1, it went to 1. I applied 1.5, it went to 1.5. I applied 1.75, it went to 1.75. I applied 2, it went to 2. But 2 was the limit, correct?
Yes, sir.
Yes, sir.
Beyond that, it couldn't go any further. It couldn't increase its value beyond it, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
That means there is a limit to Fs, and that limit is called Fs maximum.
Yes, sir.
That limit is called maximum value of Fs.
Yes, sir.
Am I clear?
Yes,
Yes,
sir.
sir.
So for any two surfaces in contact, Fs maximum is fixed, not Fs. And this I wanted to highlight. That's the reason I have made you write it equal to. The moment I say Fs is equal to μs into normal, I am referring to a force which is constant, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Because I am equating it to μs, which is a constant, and equating it to normal, which also is a constant, correct?
Yes,
Yes,
sir.
Therefore, I am suggestive of this Fs being constant. And in the same breath, I did contradict my statement by saying that Fs is what kind of a force? Fs is self-adjusting force, right, dear?
Yes, sir.
Yes,
Yes,
sir.
sir.
So if you find anywhere written Fs is equal to μs into n, you are to read this not as Fs, but Fs maximum. Got it?
Yes,
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 sir.
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 Got it, dear?
Yes,
Fs
Yes,
is
sir.
never equal to μs into n because Fs is never a constant.
Oh, okay.
Fs is what kind of a force, dear? Fs is self-adjusting force. How can you equate it to a constant?
Yes, sir.
Then what is constant? What did Newton speak about? What did he say everything on? He said everything on not Fs, but Fs maximum. Fs maximum is constant. Fs maximum is constant. which is what is also called limiting value of static friction. That's the limit. By
Yes,
limit,
sir.
what I mean? By limit, what I mean? It will not go beyond it. Is it okay? It
Yes,
will
yes,
not go beyond it. So for the given two surfaces in contact, for the given two surfaces in contact, Fs maximum is fixed. Am I clear?
Yes,
sir.
sir.
yes, sir.
For given two surfaces in contact, Fs maximum is fixed. And what is that equal to? What is that equal to? Tell me, dear, all of you.
First to N.
That is equal to
Yeah,
product of mu
What
s
job?
and normal. That is equal to product of mu s and normal. Correct, dear?
Yes,
Yes,
sir.
sir.
Am I clear to all of you?
Yes,
Yes,
sir.
sir.
Is Fs equal to mu s into normal?
No.
Sir.
What is equal to mu s into normal is the limiting value of Fs, correct?
Yes,
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 sir.
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 And this is what is known as limiting friction. And limiting friction depends on the nature of two surfaces in contact. You can decrease it by greasing, by oiling. So what it depends on? Nature of two surfaces in contact, right dear? For given normal,
Yes,
of
sir.
course, for given normal, it depends on nature of two surfaces in contact. Correct, dear?
Yes,
Yes,
sir.
sir.
And to culminate this class with one question, this is the inclined plane, visible?
Yes, sir.
Yes, sir.
And this is the block. This is mass, this angle theta, coefficient of static friction between block and inclined plane mu s.
Sir, I'm
Block
not
is
able to
not
see you.
moving. Block is not moving. Coefficient of friction is mu s, static friction. And block is not moving on the wedge, no relative motion. Find force of friction acting on the block. Find force of friction acting on the block. Quickly, dear, let us culminate the class. Find
So one
force of
second.
friction acting on the block.
Sir, I cannot see the question.
This
Yeah.
is the one visible, Krish?
No, sir. No, sir. I can just see your photo. I cannot see your video feed.
Okay, okay.
So could you just repeat the question also because it was kind of,
This is
breaking.
this is theta. This is mu s. Is the board visible now?
Sir, I'm not able to see you.
Oh, why so?
Sir, I don't know, sir. I guess it's my internet problem mostly. I don't know. Sir, I don't know about the others. Are they able to see?
So I can see you. Yours
So I
can.
can also.
Okay, okay. Okay, fine. No issue, Krish. We'll take this later. Just think about it then, all of you. Think
So you can
about what will be force of
ask,
friction.
ask one of
Inclined
them to
plane,
give me.
Krish, there's an inclined plane at an inclined at angle theta. You can draw for your case.
So I have
There's an
taken a
inclined plane, Krish, inclined at an angle theta, okay?
Yes, sir.
And
Yes,
there's a
sir.
block kept on it. Block
Okay.
is at rest.
So what should you find out?
You have to find force of
Friction
friction
force.
acting on the
Oh, okay, sir.
US is given to you.
Yes, sir. Okay, thank you, sir. I'll try.
Okay? Chalo, we'll
Yes.
call it a day then.
So
We'll solve
Yes,
when
sir.
is
later.
the test?
No
When
on
is
it,
the test?
right?
Yes, sir. When is the test?
I am planning it within next 4 days. That I can tell you for now, because there is a test scheduled tomorrow for foundation and 27th is for 12th studying student.
Sir, on
So
25th or
plan
26th, I may have the 25th or
within 4
26th. I may have that Fiji online test.
on 26th, right?
Yeah, on 25th or 26th, they give me 2 days.
Okay. So you better appear on 26th. I may plan it on 25th. Fine?
Okay, sir. No problem. Yes, sir, no problem.
Okay. Thank you, dear. Thank you, all of you.
Thank you,
Thank you,
sir.
sir.